We're going to be taking a look at two-step equations today. Our objective here is the same as it's been a couple of days here. I can solve equations with variables on one or both sides of the equation. Today our variable will just be on one side of the equation. We'll work our way to variables, or equations with variables on both sides. We've got a couple of vocabulary terms here. An equation that contains two operations is called a two-step equation. An example of a two-step equation right here with our example problem. It's going to take 2 steps to solve that equation because there's 2 operations to undo. So we'll be looking at two-step equations today. The numerical factor of a term that contains a variable is called a coefficient. And you guys have heard me use that term before with scientific notation. Scientific notation, the first part, that decimal number, is a coefficient. And then in the context of algebra here, it's the numerical factor of a term that contains a variable. Take a look at this, again, this example equation here. We have 3 terms. A term is really anything that's separated by an addition sign, a subtraction sign, or an equal sign. So 2x is a term, 3 is a term, and 7 is a term. But the number part, or the numerical factor of a term that contains a variable, only one of these terms contains a variable, this one right here. The number part, the numerical factor of that, is the coefficient. So 2 is the coefficient of that term, 2x. So you'll kind of hear us use that term throughout the rest of the time working with the equations. So you kind of get used to it, but it's just any number that's with a variable, basically. So let's take a look at our steps here. It says solve the equation, check your solution. So we're going to be looking through these steps here and work on solving this equation, 2x plus 3 equals 7. The first thing is to identify the variable so you can isolate it. That sounds like a pretty simple thing, but it's really important to make sure you know where your variable's at and pay attention where it is, because you have to get that by itself. It's not always on the left side or always on the right side. It's usually on the left side over here, but if it's on the right side, you can isolate that over there on the right side. So you got to pay attention where it's at. In this case, it's right here. Our variable is just, the letter that stands for the missing thing in the equation. And we got to get it by itself so we can figure out what it equals. In the end, we want to end up with something that says, x equals something, in this case, because it's x. So we've identified our variable. Then we're going to undo addition or subtraction is with the variable first. It's important that we undo any addition or subtraction first, because it's going to be, so just rewrite this with me here, it's going to be a lot easier to do it that way. You want to save your multiplication division step for last, because it's a lot easier to do that last. So over here with x, we've got 2 operations. X is being multiplied by 2, and there's also a plus 3 over here. And this is on this side of the equation. An equation is separated here by the equal sign. So over here we have 2x plus 3, and over here we have 7. So those 2 sides are equal. In other words, 2 times something plus 3 equals 7. And we might be able to figure that out with mental math, but what we're practicing here is using inverse operations to isolate x to figure out what it equals. So we're going to undo the addition or subtraction stuff first. So to undo that, as we talked about the other day, you have to do the opposite of whatever this is. So if it's plus 3, we subtract 3 on both sides. So 3 minus 3 cancels out. That's the point there, is we're eliminating stuff over here with the variable. So now the only thing over here is 2x. And then we have 7 minus 3, which is 4. So we've simplified that equation a little bit. X isn't quite by itself yet, but we're closer. So the next thing is to undo the multiplication or division that is with the variable and do the same thing to both sides. So if x is being multiplied by 2, we want to do the opposite of that. We want to undo that by dividing. So we divide by 2 on this side as well. And like we talked about the other day, 2 divided by 2 isn't 0 this time, but it's 1. And 1 times x is just x. So we end up being able to write just x. This cancels out, and 4 divided by 2 is 2. So we can check our solution as well by seeing, does x really equal 2? We can plug it in right here. Really probably should go ahead and plug it up here where we have our original equation. 2 times 2 is 4, and 4 plus 3 is 7. So the two sides do come out equal. There's only one thing that we could plug in for x that will make that solution, or make that come out equal, make the two sides come out equal. So that's the only correct amount there. If we tried plugging in 1, 2 times 1 is 2, 2 plus 3 is 5, not 7. So you can see there's only one thing that would make that come out to be true. So let's do some other ones here that are could be some two-step equations. We'll do these together. So for number 1 here we have negative 4x plus 7 equals 23. So the first thing is to identify the variable. This is it right here. And then we're going to undo the operations with it, starting with addition or subtraction first. So there's our addition. We're going to get rid of that plus 7 by subtracting 7. And we'll do that to both sides. So 7 minus 7 cancels out or equals 0. Bring down negative 4x. And 23 minus 7 is 16. So we also bring down the equal sign where it is between these two as well. It's negative 4x, and that equals 23 minus 7 is 16. And then we undo the addition undo the multiplication or division that we have. In this case, x is being multiplied by negative 4. You divide by exactly that. If it's being multiplied by a negative, you divide by a negative. That's because negative 4 divided by negative 4 is positive 1. We want to end up with a positive 1 here with x. We don't even write it, but essentially that's what that is. That's a 1 that's being multiplied times x, but 1 times x is just x, so we don't even have to write it. 16 divided by negative 4 is negative 4. That should be our solution. We can go back here and double check that. If we plug in negative 4 here, negative 4 times negative 4 is 16. 16 plus 7 is 23. One of the nice things about equations is you could know whether or not you have the correct answer even before you come to class and we grade this, because all you got to do is check your answers. You just plug back in what you found, and you can know whether or not you've got 100 on your assignment before you even come back to class. All right, number 2 is 7 equals a over 5 plus 5. Alright, so this one's going to be a little trickier, a little bit different than what we've done so far. This time our variable is right here, and there's a. We need to undo the operations with a to get it by itself so we can figure out what a equals. So we're going to start with anything addition or subtraction first that we can get rid of. So here's this plus 5. We'll do the opposite. We'll subtract 5 on each side. 5 minus 5 cancels out over here. 7 minus 5 is 2. Then our equal sign, and then a over 5. So the other thing we have over here with a is being divided by 5. Well, what's the opposite of divide by 5? Well, the opposite would be to multiply by 5, right? So we're going to multiply by 5 and multiply by 5 over here also. So we're going to show that with parentheses right next to the term that we have there. So 5 times 5 and divide by 5 cancels out, so all we have left over here is a, and 5 times 2 is 10. Usually we're going to go ahead and rewrite this with the variable first. Instead of 10 equals a, we'll write a equals 10. Let's check to see if that's true. If we plug in 10 here, 10 divided by 5 is 2, and 2 plus 5 is 7, and that's what that side is as well. So our answer is correct. Let's take a look at number 3 here. We have m over negative 4 minus 6 equals 5. Okay, so here's our variable. Identify the variable. Undo our addition or subtraction first. Even though this is a minus, this is still divided by, it's not really a minus, it's a negative. So divided by negative 4. So we undo this right here first. So plus 6. We bring down our m divided by negative 4. 5 plus 6, is 11. If m is being divided by negative 4, what's the opposite of divide by negative 4? Well, it's to multiply by exactly that. Multiply by negative 4 on both sides. So negative 4, or times negative 4 and divide by negative 4 cancels out, and m equals 11 times negative 4 is negative 44. So that should be our answer. Let's see if that's true. If we plug in negative 44 up here for m, negative 44 divided by negative 4 is positive 11, and 11 minus 6 equals 5. So m does in fact equal negative 44. Last one here that we're going to do on the video, number 4, is 12 minus 3/4 y equals 24. This one's a little bit different because it has a fraction in it, and so that's gonna change things up a little bit. But really, the steps are going to be the same. It's just going to make things a little trickier because there's a fraction. Here's our variable. Right there. We need to undo anything we can undo with addition or subtraction first. This is where things can get a little tricky here as well with the signs. This 12 right here, it's not attached to y. Anything not attached to the variable we want to undo first. So we undo this 12. Is this a positive 12 or a negative 12? Remember, we look at the sign ahead of it, and because there's no sign, that's actually a positive 12, right? So we want to undo that by subtracting 12. That's what's going to make this cancel out. So over here we subtract 12 also. Now when you have a sign in front of a term like that, that goes with it. Usually it's been positive for us so far, so we haven't had to worry about it because no sign is positive. But if there's a minus sign in front of that, it actually goes with this term as we bring this down. This is negative 3/4 still. Y. And then 24 minus 12 is 12. So y is being multiplied by negative 3/4. There's a couple different ways to handle this. But let's just go ahead and do it the same way we've been doing it. If it's being multiplied by something, divide by exactly that. So we're going to divide by negative 3/4. So anything divided by itself, including a fraction divided by exactly the same fraction, equals 1 and cancels out. We just need to figure out what 12 divided by negative 3/4 would be. So we could break out a calculator for that, but let's not. When we divide by something, divide by a fraction, so if I write 12 divided by negative 3/4 here. If I divide by a fraction, we can do the same thing by as multiplying by the reciprocal. You remember when you divided fractions last year, you had to flip it over and then multiply, and that was the same thing. So we're going to do 12 times, we're going to flip this over, negative 4/3. So to multiply a whole number times a fraction, you just do multiply across the top and then divide by the denominator. So you're 12 times negative 4 is negative 48. And then divide that by the denominator. Divide by 3. I wrote 4. Divide by 3. And negative 48 divided by 3 is negative 16. So we should be able to do 12 minus negative 3/4 times negative 16. And that should give us positive 24. Negative 3/4 times negative 16 is 12, and 12 plus 12 is 24. So y equals negative 16 in the end there. That was a little tough there with the fraction, but we'll talk more about that perhaps in class. But this gives you an idea of how to solve some two-step equations, and we'll see you guys in class.